talk about Android application remoting, which is very fun. And so I am Derek Ruquier, the R&D director of Cdream, and this is Pierre Jory, security IT consultant. IT security consultant, sorry.
Okay, well. Again, welcome everybody. This talk is going to be a bit technical. I'm going to let Damien introduce the very basic principles of a bunch of tools we designed to do remoting over the Android platform.
So we are going to start with the basics of remoting applications. So we have many ways to debug applications, Android applications especially. And we need some other things to practice remoting. Google developed a lot of things, a lot of features to debug applications. First of all, we have the DDMS. The DDMS is the debugging monitor server, which is used to get a lot of information about the Dalvik VM, in which run all the applications on the Android platform. We also have the Logcat. The Logcat is a kind of log implemented in the phone and providing a lot of information about the application that is run on the phone. But debugging has many drawbacks because it's a very low level. So it's very difficult to modify So it's very difficult to modify the behavior of an application or just the inner state of the application. You cannot modify values or properties inside the application. It also requires Android debug bridge, which is ADB, a tool that is very used by reverse engineer on Android platforms. And it provides only a bytecode level access to the application. The only thing you can do with it, just modify the bytecode, access some variables and properties, where it's very limited and it's not very high level. Debugging is a feature that is very cool when you are developing application, but it's not very convenient when you are a reverse engineer and you want to have an in-depth look in the application to see what the application does, how the application does this stuff, and also what are the components and how these components interact with each other. So as I said, debugging is very low level. It provides only an access to the bytecode properties, and you can also debug VMs. But the idea which we try to have when we develop Fino, which is talking about. Sorry, a bit stressed. Well, debugging has many drawbacks, and we can go over these drawbacks by using remoting. Remoting is a bit higher level view of the application, where when debugging, just give access to bytecode. Remoting, give access to the. Well, I can go. Give access to the whole application and its core components. So the idea behind Fino was to get a Java-like access to the application and be able to modify the behavior of the application, modify the core components, not by modifying bytecode or just properties, but just by having access, such access you have when you develop applications with Eclipse, for instance. And also, this high-level view of the application make us able to modify or just alter the restrictions in place when you are developing with OOP model. So when a class is private, when a method is private, or just a property is private, we are able to modify this the visibility of the class of the method to gain access to private properties or private members, and especially some information we should not have access to. The objective of this high-level view of the application is to interact deeply with the application, not being restricted by the debugging. If you debug an application, you have to connect to the DDMS, just have access to some properties and bytecode. So the main idea of remoting is just to get a bit higher and have access to the core components just as if we were developing in Java. How to do this? We developed a little tool called Fino that uses these techniques and methods. So Fino provides an access to an application by simply injecting a little service in the application. And this service provides an access to the application through an API. This API is very useful. So if we use some other tools installed on the phone, able to communicate with the API, we just can have a deep look inside the application and modify its behavior. It's a way to remote control application, but we need this service to be injected in order to take the control of the application. It's a kind of metapreter for Android applications. We are just injecting a little piece of code inside the application and communicate with this piece of code to do whatever we want with the application. But there are some limitations for this method, because you will have great access to the application. We will have access to a lot of classes, a lot of components, but there are some limitations because we only see the components that are active in the application. That means we can only see launched applications, launched activities, and also launched services, but not the ones that are not instantiated inside the application. So it's a bit limited, but it's very, very efficient enough. That is, if you have some classes that are not instantiated, you can even get access, because at any time in the application, this class is instantiated and referenced in a property. So just by having access to the property, we can get a reference on this class, and then manipulate the context of the application. It cannot send all the data to the NSA, sorry. It's not the goal here. We do not need a rooted phone to use this application. Well, rooting phone is very popular among developers and reference engineers because it provides a deep access to the phone. But rooting has some drawbacks. If you root your phone, you may void your warranty, and it can be a problem. It may also alter the behavior of the phone, and that is the behavior of the applications. And it can also be detected. An application can detect if your phone is rooted and decide not to work properly if it's running on a rooted phone. Remoting applications do not need root access to the phone. We are going to install an application, a modified application with some piece of code inside, and just communicate with the application. We do not need root access. We do not need USB debugging, and no ADB is used when remoting applications, unlike debugging, which is mandatory. And of course, any special option need to be set. You can run it as is on a classic phone. You can run it on the stock ROM, not a CyanogenMod ROM or anything else.
Well, just like Damien said, we developed a bunch of tools. The first one is called Fino, and it's the core component of our solution. The idea of Fino is to just inject a service inside any existing application so that you can install the application on any phone and have the service available, the service API available to interact with the application internals. That's the very basics of how our tool works. So you have Fino, the service that is injected. And you have two other main components. The first one is called Gadget. It's actually a service client for the Fino service API. On the Android phone, on the Android system, the service model provided by the operating system allow us to provide public APIs on the phone given an API definition. That's what Fino do. Gadget only does the opposite part. It is the client that connects to the Fino service and forward our requests from the network. So basically, we have the Fino service injected inside the application. This service provides a service API on the phone. This API is public. And we have the Gadget server, which is actually client for the Fino injected service. And the Gadget server acts as a proxy. So we have developed a TCP-based protocol to interact with the Gadget server. And every call we make to the Gadget server is actually forwarded to the service API provided by Fino. This grants us with the ability to contact the internals of the application via the Fino service from any computer of the network. You just have to have TCP access to the phone. So we do not need USB debugging. We do not need any USB cable to remote the phone, to remote the application. We can do this over the Wi-Fi network. Any wireless network will work. We can do this over the operator network, over the mobile operator network. That is very useful for some security assessments or whatever. And because we can do this from our computer with a very simple, basic TCP-based protocol, we can develop any client to interact with the internals of the applications. And that's what we did. We developed a bunch of tools, a bunch of libraries written in Python to interact with the internals of applications that are installed on our phones, so that we can, using only Python scripts, interact dynamically with the application internals. That grants us with the possibility to script modifications, debugging, anything you would like to do with your application's internals. So I will try and give you a short demonstration of how Fino actually works and how you would do it on a real application. So here, on the right, you have my phone. It's a real phone. It's not an emulator. I have it right here, and I will interact with the phone very simply, and you can see whatever happens there. And on the left, I have a terminal where I have the client installed. The famous Gadget client I told you about, the whole set of library in Python, and a very simple Python shell to interact with the application. On the right, on the phone, I launch Gadget. Gadget is the proxy server. Gadget does connect to applications that are injected with our Fino services and provides us with the network service API. So I can just start and stop the Gadget server and connect to it. So for the purpose of the demonstration, we used ADB forward because it's simpler. We do not need a wireless network, but you could use any network to connect to the application. It's just basic TCP connection. So I think it's this port. Okay. I will redo the forward. Okay. Here, I just connected my shell.py, which is the Python client, to my Gadget server. And the Gadget server retrieved for me the list of applications that are injected with my Fino service. I can now connect to any of these applications. And I have one very interesting here, the com.sysdream.demo1, that we will have a look at. So I can just start my first demonstration. Oh, snap. Actual snap. I will restart the application. So, oh, snap, the title is wrong. We're not at CCC anymore. We are at Hack in Paris. So maybe we could do something about that. First, I can list my application, and I can connect to my application if the demo gods are good with me today. Yes. So now I have a shell, a Python shell, very simple, and it's pure Python. I can do whatever I want in Python. I can script that and launch my script with the Python shell. I have my Python shell with a couple of variables already set. The most interesting one is app. App is a wrapped instance of my application. There is a high level of abstraction and a couple of utility functions that we provide with the client already. So those utility functions are developed in the Python libraries. And I have one very interesting utility functions, which is list activities. List activities grants me with the ability to list activities that are launched inside the application. So I have one activity launched right now, which is the main activities. I can retrieve this instance of the main activity of my application. And I can do whatever I want with the activity. I could finish the activity to stop the application. I won't do that. I could access the activity title, just like any variable in Python. But what I just wrote, act.mtitle, is actually sent over the network, interpreted by the gadget server, forwarded to the Fino service, and executed inside the Java application. So I actually access the property of my application which is launched on the phone with some very basic Python. And I could set the title. I could call some methods inside the application. I could set the title right and refresh my activity so that the new title is displayed. And provided with the name of my application and with the little string on the screen, maybe we could guess that there is some obfuscation technique used inside there. Maybe inside the application, strings are obfuscated. And that's what we can assess by just accessing the bytecode of the application. So I disassembled the application, and here is a Smally file. Smally is one of the low-level languages for Dalvik bytecode, the bytecode that is executed on the Android phones. And here I can see an obfuscated string in the famous class named com.sysdream.demo1.foo. Maybe I could reverse the algorithm using usual reverse engineering techniques. But maybe also I could use some tricks inside my application to access this class and to make it deobfuscate the string from me. Because the deobfuscation algorithm is already implemented inside the application. So I could get the class from Fino. Simply provide it with the name of a class, demo1.opfoo, and it will retrieve for you the class object inside Java. So I can get the class object. And I can interact with the class like any other Java class. I can, for instance, see what properties it has. It does have this famous string properties, which is obfuscated. And it also has a get method. The get method is the deobfuscation method. I can simply call it. I do not need to reverse the obfuscation algorithm. I simply need to use the application to do it for me. So that's very useful when reverse engineering, and you gain a lot of time. Maybe we could go on with some more interesting demonstration, which is more about remoting than reverse engineering. So, oh, I had some slides prepared, I'm very sorry. The principle of injecting an application with the Fino service is very basic. You just take the application, you disassemble it, you take the Fino service, you disassemble it, you merge the two, you patch your way into making it work. There are a lot of dirty hacks inside there, and you reassemble the whole thing, and you get an injected application. That's very basic. So sorry about the slides, I will just skip them and let Damien work with his remoting script.
Sorry. Well, I'm going to present a proof of concept we developed with Fino, because Fino can be used as a reverse engineering tool, as Pierre showed us, but it can also be used to create tools. And this is another aspect of this tool. This is very interesting because we can use some Java application created for the Android platform, but also use this application in order to be remote controlled. We can, for instance, create a DTMF fuzzer in order to fuzz IVR systems. So before presenting the technique behind this, I'm going to just make a short presentation of what IVR is. IVR means interactive voice response. So it's a server running that handles voice communications over the phone network.
and it provides a voice service to customer generally. I mean, if you have an answering service provided by your telco, it is an IVR service. And all the interaction between your smartphone or your phone and the IVR is based on what we call DTMF. DTMF is a method to send commands over the phone system. It's based on a dual-tone multi-frequency system, and it's generally supported by a lot of phones. Furthering the DTMF consists in sending a large amount of data, DTMF sequences, that is, over the phone network in order to see how the IVR service reacts to what we send to it. Usually, we use specific IVR testing systems to assess the security of this IVR, but it's really not affordable. It costs a lot of dollars or euros. You have many well-known IVR testing systems such as Nubot or Callmaster, which cost a lot. And it also requires specific hardware because you have to buy some GSM gateways in order to create a lot of connections, or just have multiple lines to parallelize the process. So it costs. Using Android phones is cheaper because Android phones are very affordable. It's also open source, so we can develop our own system, our own testing system. And Android phones may be tweaked to allow IVR testing. So it's something very, very tricky to design and implement, but we did it. Basically, our Android-based IVR testing system is based on an application running on the phone. Inside this application, we have already injected the Finos service that make it easily remote controlled. And we also created a Python script called DTMF Fuzz that uses the gadget proxy and the Finos service to remote control the application and then drive the DTMF further. Well, this is not very easy to create this kind of system because you need to have very low-level access to the phone because only the phone application installed on your Android system is able to communicate with the baseband. So you have to first read your phone in order to have this access. It's not working for having or being able to install a lot of applications, but the goal here, the need to read your phone is just to be able to assign an application to create a system application that will drop inside the system applications directory. Second, you have to patch ADT. ADT is a plugin for Eclipse. Maybe there are some developers over there that use this plugin and the Eclipse IDE. And this plugin have some rules that deny access to com.android.internal.everything. This namespace is used to access a lot of internal classes that are not intended to be used by Android developers. So patching ADT, is mandatory because we have to remove the rule stating that we do not have access to this namespace. So just by patching the file, we can get access to internal classes. So the goal is to create a system application with access to internal classes to get an access to the phone and the baseband in order to dial some numbers and send DTMF. We also need to build an Android.jar specific file containing all the internal classes because if we do not do this, the application will not be able to communicate with the internal classes. And also, you have to hack into the phone application. Hacking into the phone application means that we have to run our application inside the process of the phone application, which is the basic phone application installed on Android. That application is responsible of creating communications, dial numbers, and so on. And eventually, just compile, sign, and deploy the application on the Android mobile phone. So first of all, we have to create a system application. We need to import in Java a lot of classes, and especially com.android.internet.telephony.everything, because we need some classes like phone class and phone factory class. Just with one line of Java, we will be able to retrieve a phone instance. And we also need to modify the Android manifest.xml file in order to make the application running into the phone process. If we do not, if we don't do this, we will not be able to get access to the phone. Once we have a phone instance, we can use the dial method to dial numbers. And to send DTMF, we also have a quick hack, quick and dirt hack performed here. We can get the active call by using the getForegroundCall method, and then use the send DTMF on the getPhone, the result of the getPhone method. And using this, we are able to simulate a user pushing buttons on, on the phone and then send commands to the other system. We are also able to record the entire conversation thanks to Android again, which provides a very useful class called Media Recorder. And Media Recorder can be used to just save or record the conversation to a file with a 3GPP file format. But there are some limitations to this. We can only get the downlink. We will not hear the DTMF we sent to the remote IVR system, but we get the result. Eventually, to install the application, you need to sign it with the same private key used to sign all the system applications. And this is why you need to root your phone in order to install this DTMF further. Because if you do not sign the application with the exact private key used by the people who designed the ROM, your application will not be recognized as a system application and cannot be run on your phone. So this is the explanation of the routing step. So all you have to do then is just remount the root in order to push the application in the system app directory. Once done, this application will be available on your phone, and then you can use it with Fino. Well, let's do some demo about DTMF fuzzing. Yeah. All right. All right. Okay, so Pierre is going to. So Pierre is going to demonstrate this little application, this DTMF fuzzer we developed. First of all, you have two parts in the screen. On the right part, you have my phone, which is the screen with the same method as Pierre's. And on the left part, we have the console, the terminal, with our Python script displayed. So it's a kind of very short script in Python using Gadget Client, which is the Python framework we developed to communicate with Fino. So this script just dials my answering service provided by my Deco. And this application then fuzz some DTMF just by sending if I remember well, 10 random DTMF character, just simulating 10 buttons pushed by the user. And this script also records the entire conversation, so we will be able to get it later and just have a look at what the conversation was when fuzzing. Well, actually, the output, audio output is connected to this system, and you will be able to hear the conversation. I don't know if you're ready.
Well, there is a shell on my phone with all the final applications installed, and DTMF Fuzz just uses the virtual the DTMF Fuzz, which is the APK installed on my mobile phone, and providing the access to the phone subsystem. Well, can go. So on the right side, the application need. Wow.
Well,
Yes, it's better with Python. So on the right side, we have a phone, and on the left side, the controlling applications. It's well,
we don't have much sound.
maybe we're going to restart this demo. The god of demo is not with us today. No sound?
Uh-uh.
Well, so connecting to the application. Yes. So here the application is remotely controlled by my Python script and is just dialing the answering service and starting fuzzing. So no sound?
No sound.
Damn. So just the application is fuzzing and we. Yeah. Maybe I don't know.
Again?
Yeah. If it works. Of course, it's a bit unstable.
Let's try one last time.
Connecting. Yes. Perfect. So it's dialing again. Well, it's a bit fuzzy. Let it go. Well,
Perfect.
the application sends randomly. So, to be a bit more precise, the application sends randomly some DTMF sequences, and this causes the mess you heard, because the application reacts to the DTMF send, and of course there is a path defined in the IVR system, and the path must be followed by customers to get a lot of services, such as my answering service. And by sending some DTMF sequences that are not correctly handled by the IVR system, we can find sometimes we can find some vulnerabilities, some debugging access or something like that. And this is very, very interesting. Well, the system we showed you today, it's 100% based on Android system and using Fino as the remoting as a controller. Well, it costs almost anything, just using my personal phone, and just some hours of development.
Well, I'm not sure we have much time left, but we have a very last demonstration to illustrate one of the most powerful features of the bunch of tools we developed. We thought, well, what use is there of a remoting system if we can cheat at games with it? So we started thinking about what way we could try and write some software to cheat at games. And we remembered our young gamer life, cheating with the famous Action Replay on PlayStation. And we tried and developed something similar on the Android system using Fino. To do that, we developed a macro layer over the Fino service. We are now able on Fino to write some Java code on the computer side, to write some Python code on the computer side to wrap all these Java things, to compile the Java code, to send the binary over the network, and to inject binary code inside the application dynamically. So the application is running, and we inject classes. We inject bytecode inside the application dynamically over the network without having to restart anything. That's the macro layer we used on Fino. So it's very simple. You have the Java source. You compile it to an APK. You upload the APK to the phone. It's imported as a Java class. You can instantiate that Java class. You get a macro instance. And you have all the Fino Python abstractions to manipulate your new macro instance. We developed a macro that acts just like the action replay back in the PlayStation time. How did we manage to develop such a thing? It's very basic, actually. We use a simple Java class. I will not could show you the Java class we developed. It's not in there. It's in macros replay. We developed a Java class, which is here, replay.java. This Java class does one thing and does it well. It just brews the internals of the application from one point. It has very simple functions. Don't try and read the code, it's all ugly. But it just takes one variable, one value, and tries and brews all the attributes recursively until it finds some attributes that have that value. It stores the references to those attributes. And then you can filter this list of attributes that had the initial value given the new value, just like you did on the action replay. Remember, you just set an initial value. It grabs for you the list of places in the memory where that value is set. And at any time, any other time, you give the new value to the system, and it will filter this list of first memory places and narrow the search to the 1 or 2 or 3 memory places that match the value you are modifying. This works very well with gaming application, with games. For instance, I will first restart my gadget server and start a very simple game called Joules. Maybe you know the principles. No, I don't. No, please. Name update. No, please. Okay. I'm gonna try again. Yes, okay. So I have my very simple game with fancy sounds. The principle is simple, just make points, have the right score, and win the game. We'll try and hack our way into the game using Fino. So I have already injected the game application with the Fino service, so I can interact with it. Maybe it's listed. I have to follow the port again, not this one. Not this one either, this one. So, sorry, that's not the right one. Yes. So I have the list of applications, and this one is mhgames.joules.com, org.mhgame.joules. So I will run Fino inside the application. So now I have a shell that is inside the application, and I have my application. I can, for instance, list the activities, and if everything is right, I have 2 activities inside the application, only one, which is the Joule activity, and which is the one displayed currently on the screen. So I could interact with this activity, but that's not my point right now. I'm trying to cheat at the game. And what value would I like to modify? Of course, the score of the game. So I could reverse the application. Unfortunately, the bytecode has been obfuscated, so I cannot reverse it very simply. I could list all the integers, try them one after another. That would not work very well. I will instead use my macro. So I can import my replay class, which is the Python wrapper over the Java class I just showed you earlier. I import that one, and I will instantiate that one. I will give it the application instance so it can start searching from the application root, and I will give it the current value of the score. Of course, I will not start with 0 because there are a lot of 0 values inside an application, constants and so on, and it would give me maybe 100, 200 attributes. I will start with some non-null score, if I'm very lucky. Here, 10. I tell the replay module that the current score is 10, and it will search for me the variable inside the application whose value is 10. Takes a bunch of time because it goes recursively. The default depth is 3, so it will take all the attributes of the application, then for every attribute, go inside the attributes of the attribute, and so on 3 times. It takes a couple of seconds, and it does it very well because it has narrowed the search to 19 entities. I have 19 attributes inside my applications, which are all named here, which have currently the value 10. So I will modify the score. And for instance, here, my new score is of 20. So I will tell the replay module that the new score is 20. And it will scan again all these attributes and narrow the search to 2 entities. So there are 2 entities with obfuscated names that had the value 10 initially and that now have the value 20. I will play a very last time to be sure that these 2 entities are the right ones. So the current score is 30. Well, there are still 2 entities. Maybe those 2 entities are both the score. I will try and modify them. So I have a very simple set function to modify the score. I'm not sure which score would fit. This one should do the... Maybe it's just a refresh problem? Right. For the conclusion, let's try and put Hack in Paris on top scores ever of Joules. I hope it's enough. Yes, we're number 1. Oh no, we're not number 1. I should have put more. Sorry. That's it. I'm not sure you have many questions, but maybe you do. And not all of them are stupid, so please go and chat if you have any question. Yes?
Do you think you can inject your code inside an application within a phone, not having to use a computer for that?
You could inject inside the phone, but you would have to modify the APK of the application or to modify the bytecode inside the phone directories. And to do that, you would need root access, of course. But we could develop an injection application that does the injection given the root access. But it's not malware we developed. And being not a malware, we cannot inject inside applications because the Android security model is quite good enough. Well, if there are no more questions, just know that everything we developed is free. It's developed as free software, and you are very welcome to contribute to Fino. So here are the GitHub path, and just ask us. We will do merges. We will give you right access to the repositories. We'll know, but it's free software, so feel free to contribute.
For the free software, the DTMF further is not already online.
Yeah.
So we have to push it on the GitHub. But will be available very soon, I think. Thank you a lot for watching.